Does the universe, in fact, have a beginning or an end? And if so, what are they like?
Scientists remain skeptical that something can come from nothing, as the Big Bang predicts. Hawking wants to find out. His first break comes in 1965. He attends a lecture by a brilliant mathematician named Roger Penrose. Hawking hears something that grabs his interest.
Stephen was in the audience at the back of the room, and he was asking some very pertinent and difficult questions.
Penrose suggests something astonishing. There's a hole in space where huge objects disappear. If matter disappears into nothing, maybe it can also appear from nothing. This could be Hawking's first step towards proving the Big Bang. But how can there be a hole in space? The answer might lie with gravity. Einstein's general theory of relativity says gravity isn't just a force of attraction, it actually bends space. Oxford University physicist Pedro Ferreira studies gravity's impact on the universe.
Well, Einstein realized that gravity wasn't this force that acted between two bodies. It was something much more elegant and beautiful.
Einstein pictures space and time as a fabric. Planets and stars press on this fabric and create dips. In a stroke of genius, he realizes gravity is not a force, but the bends in this fabric. The dips pull objects towards them.
Let's imagine this rubber sheet is space. These glass balls that I'm holding in my hand are planets and stars. Now, if you place a planet or a star in the universe, on space, it'll create a dip. And the bigger the object you place, the bigger the dip. Imagine that the Earth is this coin, and I just send it coasting round our sun. It'll settle nicely into an orbit. It's just following the deformed nature of the fabric of space. That's what gravity is, and that's what Einstein realized.
So what we experience as gravity is actually the curve of space-time around us.
The theory of relativity does force us to fundamentally change our ideas of space and time.
When that fabric gets stretched to breaking point, something dramatic happens. A hole in space opens up. A hole down which things can disappear. This chain of events starts when a star dies. It begins to collapse in on itself, getting smaller and denser. If a star 20 times the size of the sun dies, it has a drastic effect on the fabric of space-time.
If you imagine what this means in terms of the fabric of space-time, you're just pressing down on it incredibly hard. You're pressing so hard on it that at that point, it almost tears.
The depression is so deep that nothing can climb out, not even light. This is known as a black hole.
If this star is big enough, it'll collapse to a tiny, minute point, incredibly dense. And it'll create a dip in space, so deep that if an object tries to pass by, it'll be sucked in, it'll be sucked all the way down into that point. That's a black hole.
Roger Penrose discovers that at the center of a black hole is a point of pure gravity. It's called a singularity.
As you go into a black hole, you will encounter something which goes against the laws of physics as we previously understood it. Roughly speaking, you could say a singularity is where space and time come to an end.
A singularity is like a drain, a hole in space, everything that falls down it disappears. Hawking wonders if the opposite could be true. According to the Big Bang Theory, all the universe suddenly sprang from a point of nothing. Could this hole be the key to explain how this happened? In a moment of genius, he sees the solution. It's elegantly simple.
I soon realized that if one reversed the direction of time in Penrose's theorem, the collapse became an expansion.
Instead of sucking everything in, a reverse black hole explodes out in a shower of space, matter, and time. Exactly as the Big Bang Theory predicts. Against a sea of skepticism, Hawking proves the universe suddenly appeared from nothing. It sprang from inside a singularity. The debate is over.
The universe must have had a beginning in time. This was finally proved by Penrose and myself, on the basis of Einstein's theory of relativity.